Hello and welcome to this edition of our global webinar series. Today's topic is magnetics basics. My name is David Adib and I am a senior technical marketing engineer here with Kemet in Florida, and I will moderate the webinar today. We're very pleased that you find the time to join our webinar. Our presenter today is LeAnna Weakley, and LeAnna is from the MSA group. She is a technical product manager. With this information, I'll hand it over to LeAnna. Good morning to you, LeAnna. Thank you for your time today. Please tell us about yourself and proceed with your presentation. Thank you.
Thank you, David. Can you hear me?
Yes, I can hear you fine.
Great. As you said, my name is LeAnna Weakley. I'm the technical product manager for our magnetics group. And today we'll be discussing our automotive common mode EMI chokes. That would be our SCT and SCR XV series. So we'll start by discussing the EV market, which is obviously a growing market within automotive. EV sales grew by 41% in 2020, and that's with the pandemic. It has a 4.6% share in the new vehicle market currently, which is forecasted to grow to a 27% share by 2030. So you can see that it is growing very quickly. There are also many governments pushing towards climate goals that will certainly exacerbate this. So we are seeing many trends within the EV market. Of course, one of those is higher voltages. Now, BEVs, or battery electric vehicles, and plug-in hybrids do have those higher voltage electrical systems, usually around 400 volts. We're seeing up to 800 in those fast charging type applications. Now compare this to your traditional 12 volt internal combustion engine. You're going to need higher voltage rated componentry. Now these high voltages do allow for the same amount of power, but less current. So you can use lighter wires. So your wiring harnesses are much lighter. Your system will be more efficient. And that is the goal with electric vehicles, right? You want to get as far as possible without having to recharge. You want that efficiency within an electric vehicle. So you will need those high voltage rated componentries in order to keep these high voltage systems. Now for high voltage componentries, or really any voltage rated for this component type, there is an insulation standard and design that does need to be met. We use the IEC 60664 standard with our material type, which is material group 1, and we use pollution degree 2. 5 millimeters is what is required for creepage distance at 1,000 volt rating. We meet this distance through using an insulation housing. You can see this plastic cap on top of the magnetic core in the top right screen. This is to ensure that that 5 millimeters is met to make sure that 1,000 volts is safe for use. Now there are more and more electronics per vehicle, of course, moving from internal combustion engines to a fully electric vehicle. You're going to have more electronics. That just makes sense. So if we look at the trend of the number of electronic components in a car as a percentage of the total car cost, back in the 90s and early 2000s, it was between 15–20% of the total car cost. Now in 2020, it's about 40%, and that's expected to grow even to 50% by 2030, if not higher. Now, more electronic components means that you do need higher reliability parts. So if you look back to like internal combustion type engines, your electric componentry was more like maybe you had a seat heater, your stereo, your AC, that was about it. So if those systems were to fail, it was not a safety issue. Your vehicle would still drive, whereas now these electronic components are within those safety type systems. So you do need high reliability and especially high performance at those higher temperatures. Of course, you'll want your AEC Q200 compliant components. Make sure that they pass those tests and will work within your application. And you want these parts produced in an IATF qualified plant to ensure that quality. And you can see our certificates of registration for IATF below. Now, I mentioned high performance at higher temperatures. We are tackling that starting from the ferrite material itself. We do produce all of our own ferrite materials. Here in the blue, you see our high permeability ferrite materials going anywhere from a permeability of 5,000 mu up to around 18,000. And in the gray on the right, those are our newer materials for high temperatures. So the 5HT, which came out, I believe, a couple of years ago, is rated up to about 220 degrees C. And our 7HT, which came out this year, is rated up to 180 degrees C. And that is the material that you'll see used within this product series. And then under development, we do have our 10HT, which will have a little higher permeability and will be rated up to 150 degrees C. Here's a breakdown of those material characteristics, frequency characteristics. On the left, the newest 7HT is that dashed red line. You can definitely start to see the differences, the main differences between this material and those high permeability materials in the graph on the right, which is the temperature graph. You don't get that decline in permeability until around that 180 degrees C temperature mark. Now, if temperature isn't something that you are particularly interested in, or 120 degrees C is fine with you, these products will also be offered in what you see in the pink line, the S15H. So we use all of these materials within all of our product series. And today, of course, we will be discussing the SCR and SCT XV automotive series. And we do have the SCN XV series, which is dual mode, that I'll be touching on, that is coming soon. So this is our automotive grade SCR or T or N XV series. We've been shortening it to SCXV, just so you don't have to go through all those letters. But these are rated up to 150 degrees C if you are to choose that 7HT material. So you can see that those two materials are available. The part sizes that you see on the left of the chart are the new products that are currently available, available in horizontal and vertical layout. One thing to point out for this series is that they are rated up to 1,000 volts. And as I mentioned earlier, that is definitely where the automotive market with EVs is going, is those high voltage ratings. So that's what this 1,000 volts is really designed for. The three part sizes that we have right now are 19, 25, and 29 millimeter diameters. If you're not concerned about the high temperatures going up to 150 degrees C, the S15H is available as well, which will be rated up to 120. And these go up to 35 amps. Coming soon, we do have that dual mode type product, dual mode choke, which will also use the 7HT high temperature material and go up to 19 amps. And then under development, coming out, I believe, second quarter next year, will be our 39 millimeter diameter product, a bit larger, but still available in those two different materials, going up to 50 amps. So as I mentioned earlier, of course, high voltage automotive systems are really what we're seeing growth in, and that is kind of what we have targeted with these products. Usually in the power conversion systems is where you will see those high voltage ratings. Some examples might be on the top left, a DC to DC filtering of applications based on maybe PWM or MCU type automotive inverters. So this shows a heating system in an electric vehicle that might use something like our SCT29 product. In the top middle, we have onboard chargers that these could be used for EVs and plug-in hybrids, for input and output EMI filtering. On the right, we have auxiliary and power grid converters. That would be for your high voltage, again, 400 to 800 volt DC converters versus your 12 to 48 volt applications. So this might use something like the SCT29 series. Now the application on the bottom isn't necessarily high voltage, but we are seeing interest in this type of application with these products due to the reliability. So for something such as a mild hybrid type application, filtering 12 or 48 volt steering, fan drives, and compressor systems for input filtering, we are seeing interest in those smaller 19 millimeter diameter type products like the SCT19. Going a little bit more in detail into some of these examples, here on the left we have an e-compressor. Now a traditional air compressor in a vehicle was lower voltage and belt driven, which as you can see here is not the case with an e-compressor. Higher voltage is running this system, so you will be needing a higher voltage choke type product for EMC purposes. So our SCT series might be something that could be used in that system. Then on the right, we have a PTC heater, positive temperature coefficient heater. These run on high voltage batteries to maximize the power delivered to that heater. You want as much power as possible to heat up those coils. So something like the SCN or SCT might be used within this type of system. Again, these will be high voltage systems. High voltage parts are needed. Going a little bit more into detail about what we currently have or what is currently being released within the SCR and SCT XV portfolio. The R in SCR stands for that S15H ferrite type material, whereas the SCT is that high temperature 7HT that we've been discussing. All of these core sizes, the 19, 25, and 29 millimeters, are available in vertical and horizontal layouts, a total of 144 different part numbers. And you can denote the core size in the part number after the either SCR or SCT. Then of course, XV will denote that this is our automotive series. Here you can see within these three sizes that are currently out, the range of inductance and current ratings that we do have. These inductance values are measured at 100 kilohertz, and current values range anywhere from 5 to 35 amps. Here are the frequency characteristics of some of these products. On the left, you have the SCR, which remember is the S15H high permeability material, whereas that on the right, the SCT is the high temperature materials. This just shows the differences between the performance of those two with the frequencies. So of course, the higher permeability material, the S15H, will have a little bit of a higher inductance with frequency than that of the high temperature product. And then I also wanted to touch on our dual mode choke coil as it is coming out very soon. This will be within the same series, so still 1,000 volts, still fully AEC Q200 rated. So this is a dual mode choke, which means it has common and differential mode performance. So in an EMI filter, you might have a common mode and 2 differential mode chokes. You can replace that with just one of these. You can see in the picture that the shape of the core is a little bit different. It is an oval versus just your typical circle. That helps with the leakage flux that we're trying to increase to get that differential mode inductance. The winding structure is also very important for that. You can see in the chart a difference between a typical toroidal common mode choke versus our dual mode coil. There is a 30% increase in that differential mode inductance. These do use that 7HT high temperature material as well, so will be rated up to 150 degrees C. And finally, this is our roadmap. The SCT and SCRXV series, those 3 sizes we've discussed, are releasing this quarter. The dual mode will release in the first quarter of next year, and then that larger size, the 39 millimeter core size, will be launching in the second quarter of next year. Are there any questions?
All right. So LeAnna, I do have a question. Where are those chokes manufactured?
These would be manufactured in our Vietnam location.
Oh, okay. And if, say, for example, if a customer wants to order samples, how can they do that?
We do have product within the channel, so you can look at DigiKey or Mouser. If you don't see it on there, of course, you can reach out to your sales representative and we can get you some samples that way as well.
Oh, okay. All right. Thank you. So I do have a couple of questions here for you that came through the chat. The first one says, at which current is the LF chart measured?
I am not sure on that one.
Okay.
I would have to get back to you on that.
All right. That's fine.
What it's measured at.
All right. And another question that came in says, hello, do you have some parts, SCN, I guess we may have just answered that, SCN35XV available with a current more than 50 amps? Or maybe we did not answer that.
So the SCN is the dual mode. More than 50 amps, no. Those, I believe, go up to 19 amps.
Oh, okay. All right. All right. Okay. Well, these are all the questions that we have for today. So thank you very much, LeAnna, for your time and the presentation today. This will bring us to the end of this session. Thank you to all of our attendees for being part of this today. We hope to see you next time. And until then, have a good day. Thank you and goodbye.
Thank you.